So thanks for having me here, and it's been a really great 2 days in terms of learning a lot more about invasive species and a chance to think more about how phenology connects. So I'm going to give an overview of some research that some of our collaborators have done, the tools that NPN provides, and then try to leave a good amount of time for discussion, because it would be just great to talk more with you guys and hear about which parts of this you're more interested in. Let's see. Okay, so I think we've probably covered this already, but the way we define phenology is the study of the timing of plant and animal life cycle events like flowering, like migration, how these are responding to climate. And the USA National Phenology Network, we've existed since about 2008, and we're funded by the USGS ecosystems to the University of Arizona with the goal of advancing the science of phenology and then supporting the use of phenological information in decision making. And so how we do that is we make phenology data models available and encourage people to participate in phenology monitoring. So I'll talk a little bit about both of those pieces. The main app, since we're just coming off of a talk about apps, the main app and way that we go about this is our Nature's Notebook program. So this project has standardized protocols for monitoring plants and animals over time to look at their phenology, the timing of their life cycle events, like when are they leafing, when do you see open flowers, how many open flowers are on the plant. For animals, it's maybe presence of caterpillars, presence of adults, individuals at a feeder, that kind of thing. We have web and mobile apps that allow people to collect that data, and we offer both, so people can still download paper data sheets and then enter that online themselves, or they can use the mobile apps. We have campaigns, so we have 1,000 species, but then we're like, okay, well that's almost meaningless if there's just like a little smattering of data on species across the country. So we've really tried to focus attention on about 20 campaign species of primarily plants. So it's deciduous trees. There is a invasive species campaign I'll talk about in a bit. So those are kind of national or regional data collection efforts. And then both individuals and groups participate. So that we're this national program, small staff, 10 people, we're creating this IT infrastructure, creating these standardized protocols, trying to amass data on this sort of understudied area of phenology, when are things leafing and blooming. And we've made this sort of extensible program. So, a naturalist can observe in their backyard what a shrub is doing over the season, or an extension group like Esperanza Stanchioff in Maine has taken our program and picked her own 20 species, trained people to work in their backyards, has her own science management questions that she wants to get out of the data. So it works both at the group level and for the individual. And then, we have like a national park who has a question about, flowering across an elevation range. And so then we have technicians collecting that data. We have quality assurance, quality control measures. We have, at this point, like 28 scientific publications that have been written using the data. And also, because we're USGS funded, we've had to enter and succeed in this realm of federal compliance. So all of our apps and tools are in compliance with the Privacy Act and with the Paperwork Reduction Act. And so that makes it easy to work with federal partners who sometimes can't point people to programs who aren't in compliance with those pieces. So that was a barrier in some ways, but I also wanted to mention that recently there has been more of a push or encouragement from the federal government towards citizen science. So we saw this Jonathan Holdren memo in the fall of 2016 that said, hey, citizen science is a great way for the federal government to engage people and to get more data. And then that was formalized in the Competes Act. So we do have that kind of blessing, and there's like a citizen science liaison at every federal agency, and so I think we're starting to see some movement on that, which is great. And that's all I wanted. Okay, so getting into the phenology and invasive side of things, I am going to talk about the relevance of phenology in terms of predicting invasive species phenology, in terms of detection, and in terms of removal. So as context for the long-term predictions, and we sort of already heard a good amount about climate change, but I wanted to just emphasize the fact that spring is getting earlier. You know, this is the trend that we're seeing across the country. We have an indicator of spring that's based on a legacy data set of lilac and honeysuckle observations. So if you are willing to just please for the moment accept the definition of spring as the timing of lilac leaf out or lilac bloom. I know, you know, it might be a lot to ask, but there's no standard. It's very difficult to come up with a standard measure across the country. And so, so if we take that as our indicator, we see that it's happening earlier over the last 100 years. This is an indicator in the National Climate Assessment. Oh, just to talk about the graph, the middle line is the 1901 to 2000 average, and so the green springs below the line are earlier than average, and the blue springs above the line are later than average. And so you can see a trend towards earlier spring, especially in the last 30 years. And that's happening. The trend is a date per decade. And of course, there's a lot of interannual variation. And this is just like 1 point per year for the whole country, when obviously there's a lot of spatial variation. There's, you know, things aren't coming as earlier in the southeast. The northeast is seeing more dramatic changes. So there's a lot packed into that. And this is possibly a digression, but I wanted to throw this up here. We also now have this gridded spring index across the country that shows this regional variation. And this is for 2017, where we see that in some parts of the country, spring was, I mean, we had to change our legend in the middle of spring because it was 30 days earlier than usual in this, right there in the mid-Atlantic. And so this, I mean, I kind of have two questions about this. Like, one, is this considered a disturbance or an extreme of some kind? You know, I've been thinking about those words. I've been hearing them in the last couple days. It's certainly, having spring come 30 days early has a lot of effects, and I think, you know, maybe could be argued is a disturbance in the system. And then also just to point out that we got a lot of media legs off of this product this spring. It wound up in a lot of outlets. It was on Al Roker and the Today Show, like, showed our map, like, for, you know, 3 seconds. So, you know, I think it's one of those things where climate change gets local and gets real, and people talk to you about it. Like, this isn't normal. Like, spring is acting differently than it used to, and so to be able to point to something, and so we're kind of working on this in the climate communications direction. So back to long-term predictions. As we heard in Bethany's talk, species with early phenology are able to, and especially if they're flexible and they're ready to respond to that early spring, they can fill a vacant niche and get that competitive edge. And so we've seen a bunch of work that backs that up. And one campaign that we have that kind of builds on that idea is with collaborators at Penn State, looking at invasive shrubs and if they have extended leaf out, whether that's giving them a competitive advantage and how that's working out. And so we have observers, I think, even including into New York and Pennsylvania, looking at these species. And some of our organized collaborators and individual collaborators are collecting this data, and the research team is using it, and it's this nice opportunity. We have learned to add more structure to these campaigns so that people know why they're collecting, why they're being asked to catch leaf out in these shrubs early in the spring. The researcher that we work with, Erin Maynard, is like obligated. I think she's also happy to give a couple of webinars that give the results back to the observers so they know, you know, like, yes, this is meaningful, this is why you're participating. So we've learned a few things about that for sure. Another project that they used NCAN data, but we didn't particularly otherwise collaborate with them or do a campaign, was this one looking at ragweed. And so they used NCAN data to look at the time between maturity and when seed set, to know whether there was enough time for that to happen at the northern range limit. And they found that, oh no, you know, based on day length and temperature and phenology, the species won't be able to get past this latitude. And so then shifting gears into this short range prediction arena, and then we have kind kind of building on Jenica's talk yesterday about different ways to model phenology. So like the basic idea is like, okay, we know when leaf out happens. Like, let's say we have a great data set for red maple across, the whole eastern half of the country. We have, 100,000 records of leaf out. Can we predict what led to that leaf out? What was it? Rainfall? Was it winter chilling? Was it growing degree days? And so there's a lot of different ways to do that, to build those models, process models, or otherwise. But we've been looking especially at these growing degree day threshold models because they're like the simplest thing, and it's possible to forecast then out like 6 days from now, this is when this plant might leaf out or this insect might emerge. So this isn't a great way of explaining this slide, but basically it's like we're aiming at these threshold models, recognizing that a lot of other stuff is happening, and the more complex models might be, there's trade-offs in terms of accuracy and what you can do as far as predictions. Because you can't obviously predict spring T minimum until spring is over, or have that data. So, so in our Nature's Notebook program, we do have maybe a dozen invasive species that people can observe, and so this, I didn't update this from last year, but we have maybe between 1,000 and 7,000 records on these invasive species in our database, and we hope that this is useful for building models on these species. And then also, we've noticed too, as we've gone into this and looked at these growing degree day models, that they're often like for one spot. Like in Nova Scotia, this is the number of growing degree days for red sorrel Ramets to emerge. But what we're wondering, and we've seen there's all this genetic variation. Is that really the same threshold for somewhere else? If we want to make a national map of when this is going to be happening, we have to have locations across the country, and so we're trying to leverage those standardized protocols and data collection from all over to be able to start to build models that come from multiple places around the country, but we don't have that in very many cases at this point. So the basis for this next set of products I'm going to talk about are these accumulated growing degree day maps that we've created. Basically for every day, it just shows you for this pixel how many growing degree days have accumulated. So this is for July 26th. And then, so if you were to make the leap of faith that this red sorrel Ramet emergence threshold that was developed in Nova Scotia of between 110 and 265 growing degree days, let's say that that's true across its range, then you could use our maps to look at when that threshold will be, or where that range has been met. So what's colored on the map are showing areas where, as of March 15th, the growing degree days were more than 100 and less than 300 had accumulated. Does that make sense? And you can do this either now, I looked back to March 15th because I wanted to show, the north and south bounds, but these are available using the NSEP forecast data up to 6 days into the future. So if it was, you could have gotten this map on March 10th to estimate when it was going to emerge. Similar story, emerald ash borer. On June 15th, 6-day forecast for where the growing degree days are greater than 500. And then we've also created this anomaly based on the 1981 to 2010 period. So you can see how many growing degree days have accumulated this year relative to normal for each pixel. So this is for July 18th of this year. And you can see that it's been, warmer by 800-900 growing degree days than normal, and that's very congruent with the early spring. It was a warm and early spring, and this isn't telling you, was all this extra warming in February or was it in March? It's just telling you, as of today, we're this far ahead. But so then we did also create a trace so that you can see for any pixel how that's happening. So the black line here is the 30-year normal. The blue line is 2017. The red is the forecasted. And the blue is the observed. So you can see, like, on the green line here, as of June 10th, we were 5 days ahead in growing degree days. But if you scroll back here to March, we're like even further ahead. So you can kind of see as we're going through the year, is it warming up faster than normal? Should I be expecting to see very growing degree sensitive insects or plants ahead of when I usually see them or behind when I usually see them, to kind of watch this as it comes along. So switching out of prediction just briefly into detection. This is a project out of the San Francisco Inventory and Monitoring Network of the Park Service. They've created this nice calendar that looks at when invasive species are detectable. So I think I made a zoom in here. So you can see their key, they have the phenology colored, so new growth, flowering, fruiting, senescence, and dead leaves. And then their detectability scale, can you see it from these different distances, from not detectable to easily detectable. So I think that this helps them plan their management in the sense that they know when different species are going to be in a phenophase that is readily detectable. And then in terms of removal, I wanted to give this example of Midway Atoll National Wildlife Refuge, where they're looking for the number of days, the minimum number of days between initial growth and seed drop for golden crownbeard, so that they know the frequency to plan the visits to the infested sites. So they found the other complicating factor here is that there's doesn't ever stop. It runs twice through the year, and so the August to October run was 31. Was the minimum number of days was 31. The December to April was 89, and so they know in different times of the year how often they have to go out to treat to catch it before it sets seeds. And then this example, we collaborated with folks at Sorrel National Park and USGS, looking using remote sensed green mist data, PRISM rainfall data, and citizen science collected buffalo grass observations to figure out how much rainfall was necessary for pixels that were very highly invaded by buffalo grass to green up versus native vegetation. And basically sort of leveraging, I think the point I want to make here is about the value of integrating different data sources. So if you taking remote sense data with ground observations, with climate data, you can paint a richer picture. And they were able to see that it was a certain number of fewer prior rainfall periods were necessary to green up the buffalo grass versus the native vegetation. So that gives them this window to chemically treat buffalo grass before the native vegetation grows up. And then this is also a new way that we've presented the ground data, the observational data on our website. So people have been, this is sort of for the whole East Coast, I aggregated all, the y-axis is the proportion of individuals with yes records. So this is all of the individual garlic mustards that people are observing and all of the individual trillium that people are observing. Of those, all those individuals, how many had any yes record for initial growth in this time period. And so you can see this is for this year, you can see that garlic mustard greens up. It has initial growth a bit before trillium. I picked trillium kind of randomly, but for another native species of interest, you could again see if you have this management window for your invader before your native is out, or sort of also you could use it to answer that question: are they coming out earlier? Are they getting this competitive advantage? So it kind of works in both ways. So yeah, I think I just wanted to share where we have these tools. We have the visualization tools where most of what I've shown came from. We also have web services that people can hit to kind of directly get these and pull them into a GIS or other environment. And then you can download the observational data as like Excel files. And then I'll just also mention, I know Jeff Morissette was on the phone yesterday, but we're collaborating with him on a grant funded by NASA to pulled together a lot of different kinds of phenology data, and so part of the grant is fairly IT focused, and it'll be at the LPDAC. And but the 3 use cases that he's chosen, especially because of his new role at the National Invasive Species Council, are going to be focused on these invasive species questions. So the shady invaders one, looking at answering the question, do invasive shrubs have a lower chilling requirement than native species? And then also leveraging the NEON infrastructure, which has towers and airborne sensors, to see if we can do better at detecting invasive species. And then there's a remote sensing angle with this project on mule deer migration in Wyoming, looking at the impact of cheatgrass on when you see green up in the satellite, and potentially what that means for forage for the mule deer. So I think you wanted to put this project on your radar and let you know that there's sort of some more invasive species research happening, and hopefully to be of use to the community. So yeah, hopefully that wasn't too long and we have time to talk about things. I appreciate your time.